Okay, so pointers can definitely be a tough topic to approach, especially if you don't have any background knowledge of computers. Um, an important thing to understand with pointers is what they're actually affecting. So, pointers address a really powerful point of the language, which is the ability to directly manipulate memory. So, C++, this is a very powerful thing, and this is a very dangerous thing because of unexpected behavior that can come from potentially incorrectly accessing memory or accessing memory you're not allowed to. Um, that would be you would get a segmentation fault for that if you try to access memory you're not allowed to. But if you have no idea what memory is, a really good way to think about it is it's the place that your computer stores the data it's working with. So, like active applications are stored in memory, um, programs are run in memory, um, and basically the way it's set up is it's set up into thousands, tens of thousands of chunks of individual memory blocks, and each of those blocks has a specific address. Like it would be like if you were to think about this on a street, right? And each of these is a different lot. There's not necessarily anything on that lot, but each lot is identified by a unique number, like how there is a unique address, at least for the localities generally. Um, so in C++, this would be a way, oh, wait, don't forget the semicolon. This would be a way to declare a pointer. Um, and a good way to think about it is the pointer variable itself is going to store one of these numbers. When you are actually using C++ and let's say you were to assign this and print out a pointer, you would get a lot longer because in actual computers, be like 0, F6, 532, or if something like that, which is the actual, because this can store a whole lot more addresses. But for demonstration purposes, we're only going to work with a five address memory. Okay, so back to this declaration. So the star is what indicates that a variable is a pointer, and the int indicates what data type it's going to point to. A potential explanation for this would be that different data types have different sizes. So depending on what type, you might need to, because the computer itself does a lot of the management and you have to specifically request access to memory. So let's say an int pointer takes up 2 blocks, but a char pointer takes up 4. That's incorrect. They take up the same amount, but that's just an example. Um, so right now, this int pointer that we've declared points to null. Null is a special keyword. Generally, it'll be capitalized, or you can also use the keyword null pointer. But that basically says, hey, I'm creating this and I don't want it to point anywhere. And this can be useful in a variety of scenarios. Um, let's say you want to say you've reached the end, you're going through memory, and when the value of this equals 3, you set it to null so that you know you're done. That's one example um, of using null. But let's say we want to assign this to a value. So let's say we were to do int, let's just create a variable, right? Int x equals 8, right? Don't forget our semicolon. So int x equals 8. Now when we run this, this x equals 8, it's managed by the compiler and it's given some place in memory. Let's say it's given 4, right? So this is 8, and this is a little known thing, or at least for beginners, it's little known that every variable that you've declared or are going to declare has a pointer to a location in memory, which can be accessed by using the ampersand. So if we were to assign this, right, if we were to do PTR equals the, I'm going to butcher this ampersand, equals the address of X. So when we put the ampersand in front of something, we say, I want the address. I don't want the value of X, which is the context you're used to accessing it in. I want the value of X, or I want the address of X. Okay? Now the pointer points to X, right? So, and X equals 8. And so this is, so what's the point of pointers pointing at stuff if we can't access the values located there? So to access the value, let's do just C out, right? C out. So this is kind of one of the annoying things with C++ is depending on the context, symbols can have different meanings. So to access the value of the address that PTR points to, you would use the star sign. And this is what's called dereferencing a pointer. So let's say hypothetically, we move this line. Let's do PTR and then NL, right? We're doing standard stuff. If we were to move this line up here, right, before we made this actually point somewhere, it's still pointing to null, you would get an error. So if you see dereferencing a null pointer, the problem is that you don't have this pointing anywhere, so there's no possibility that you would be able to get a value and then the compiler doesn't know what to do, right? Another potential problem, let's say hypothetically we were to have, and this is where kind of the danger of working with pointers comes in. Let's say hypothetically we were to do some totally awesome code right there, and then we did this, then we did this line again, right? We were to do this, star, PTR, end L. But in this awesome code, let's say we had another pointer point somewhere else, point to 4, change its value. But we didn't want that to happen. This is just an example of the dangers of working with pointers, is what's located here might not be what you need. Let's say our epic code goes through this and makes this 4, right? Which we wouldn't want, and that's definitely something, like let's say you're getting random values or whatever, that might be one of the problems. Another thing to consider is to save on resources. The computer doesn't change what's in here when it's done. So let's say Microsoft Word was using this memory and it has like, let's just say it's got the characters Word, W-O, then the number 4, and then P, right? So let's say you made another pointer, right? And you had it point to 02, right? So you just did another one. Int PTR2 equals, so this is the address value, equals 02, right? And this could change depending on what program was using the memory you had been assigned last. So, and this might have some unintended consequences because your code may be relying on pointer 2 being equal to some value, but it's not actually equal to that. And that's one of the potential problems when working with pointers. So generally, it's always good to make sure you properly assign it when you're working with it. Okay, and that should be okay introduction to pointers. There's more to go over with them with assignment, but we can cover that in another video.